this isn't some faraway planet. These Martian-like landscapes are found in Iceland. It could almost be a scene from science fiction. Seemingly in the middle of nowhere, these towering machines are guzzling up carbon dioxide, a global warming gas. So, could this much-hyped technology help us fight the climate crisis?
Mammoth is the world's largest direct air capture and storage facility. What you see here are 12 of our collector containers. When the plant is fully operational, we'll actually have 72 around the plant. That will enable us to capture 36,000 tonnes of CO2 every year.
It works like a giant vacuum. Each of these units is the size of a shipping container and has a dozen powerful fans sucking in the surrounding air.
They pull in an Olympic swimming pool's worth of air every 40 seconds. And then inside, a filter separates the CO2. In the atmosphere, its concentration is very dilute. Capturing even small amounts requires lots of energy. And Mammoth gets both power and hot water from the nearby geothermal plant.
For us to do direct air capture effectively and efficiently, we want to make sure that we're using energy that has a low carbon footprint.
Some would look at this and say, hang on, where's the industry? Would it not be more efficient to have one of these next to a factory that's actually making the pollution?
Carbon dioxide tends to just disperse and diffuse in the air. The effectiveness of direct air capture is not dependent on being located close to industrial emitters.
Okay, I'll let you show me where the CO2 goes.
That lowest line here, that's actually the CO2 that's coming from those 12 containers outside. These two balloons are a really good visual representation of what, in total, 1 tonne of CO2 looks like.
This tower then works a bit like a soda stream, dissolving the pure CO2 in water.
From the top we have water coming in, so it's like a shower. It's sort of at home if you're making sparkling water, same idea.
That fizzy water is sent to these igloo-like domes.
So here we have one of our injection wells. Please come inside. This well is going 700 meters down into the underground here.
The CO2 and water is pumped deep into the basalt bedrock, where it reacts and turns to stone.
So you've got a couple of rocks
Yes,
there.
exactly. I'm a geologist, so I brought rocks. This is a fresh basalt here, actually from one of the last volcanic eruptions here in Iceland. You can see there's a lot of porosity in here. Here you can see there's a lot of these pores now filled with white specks. Some of these contain the mineralized CO2.
And Carbfix says that happens pretty quickly.
We're not talking about millions or tens of thousands of years. Around about 95% of the CO2 was mineralized here within 2 years in the pilot project. This is incredibly fast, geologically speaking.
Mammoth is Climeworks' second commercial plant and almost 10 times bigger than the last one, collecting 36,000 tonnes of CO2 annually. About the same amount as taking 8,000 petrol cars off the road. But it costs a whopping $1,000 to remove just 1 tonne.
What do we mean by removing emissions?
Among its customers are Microsoft, H&M and Lego. Worldwide, more plants like these are on the way, though they'll still only remove a fraction of what's needed. And despite calls to slash our emissions, the CO2 we churn out continues to grow.
Do you think direct air capture can be an effective tool for removing carbon?
We release about 40 billion tons of carbon dioxide to the atmosphere every year. So this won't make a dent into the big problem. But I think you should use all methods and methodologies to fight this problem.
What's it going to take to scale it up, bring costs down, and make it really impactful?
By the end of the decade, We want to be at a cost of capture of between $300 and $400. Technology improvements will help drive down costs. A second lever will be scale.
The team says this is just the beginning. Mammoth will soon be dwarfed by another much bigger plant, Project Cypress in the United States, which will eventually capture 1 million tons of CO2 each year.
From Mammoth to Cypress, we're now looking to break that hundreds of thousands of tons of capture capacity a year. I really do believe direct air capture and other engineered solutions are going to be able to get us to the point that we need to help fight climate change.